All right, so we left off here after number 10, where we just ran over this, how to export figures. Let's take a look at what that looked like. All right, so now we're wanting to run this model again, but we want to improve our fit by connecting direct paths between SMA and SRA and job score 3. So right now we have just the path between SMA and GPA and education 3, and same for SRA, and but we want to connect some direct paths to that job score 3 variable. And so the only difference here is now we are adding for job score 3, whereas before on model B, we just had GPA 2 in education on job score 3. All we do for this model is add SMA and SRA to create model C. We run our sim function once again. Just as a quick reminder, this missing equals ML is using our full information maximum likelihood estimation to fill in missing data, and the fixed equals X, or fixed X equals false gives us those correlations in our output. So then when we look at our summary, what happened with our chi-square and degrees of freedom here? Yep, so everything's zeroed out because now that we've made that those additional connections, we're back to having a just identified model. So we have a perfect prediction in this case. Looking at our RMSEA, same thing happens here. It can't compute a p-value because you can't get an RMSEA on a perfectly fit model. And if we run this diagram now, same thing as before, just changing our model here. And so now you can see we've got those direct arrows between SMA, SRA, and job score 3 up here. So looking at these paths to see if there are any that are non-significant, we're coming to the regressions here. And keep in mind that what we're looking at is this STD all, the standardized all. And just as a reminder, this standardized LV is when just the latent variables are standardized. But what we're working with is this column here. That's when all the variables are standardized. So look.
So, yeah, I'm going to interrupt for just a second. What we have done here is we started with a first theoretical model to explain ultimate outcomes, the 3-year or 3 time point outcomes. And the first model we ran didn't provide good fit. We had looked at some modification indices and thought about some theory and thought maybe it makes sense to add paths from SMA and SRA to predict the final outcome, because after all, those are kind of associated with something like, I don't know, IQ, for example, or just general intellectual capacity. So maybe we ought to include those direct paths. We did that, but now we have 0 degrees of freedom. Again, we don't like 0 degrees of freedom because it doesn't actually allow us to evaluate the overall model fit. So a common thing you're going to find when people run path analyses or structural models is that if they are perfectly identified modified, so with 0 degrees of freedom, they're often going to do a next step, which is called model trimming. And the model trimming means that you trim off or you release, you no longer estimate the non-significant paths. What that does is it buys you degrees of freedom, and it's the equivalent of following a Wald test, which is deleting paths that don't actually contribute to model fit or that are not significantly different from 0.
All right, so looking here then, which of our paths are not significant? GPA2 and SRA, which we see right here with these two rows. RP is 0.45 and 0.89 respectively.
Casey asked if it becomes exploratory once again once you trim, and the answer to that is yes. Trimming is also considered a post hoc analysis or post hoc modification. So if you, for example, theoretically should have GPA2 predicting job score 3 because it's proximal and it's related and whatever, and it doesn't, and then you decide to cut it from a final model, then that does move it back into exploratory. A lot of times people will not talk about trimming non-significant paths as exploratory. So in a lot of papers, you'll see them presented as here's the hypothesized model, here's the final, or here's the model with all the indicators, here's the trimmed model, which they're really just saying to increase parsimony, we took off the non-significant paths, but it is still technically exploratory.
All right. So is there anything else that we want to go over with this model, Anna, or are we running straight into our last one here?
I think we're going to go right into our last one because we can't look at fit indices, and we could look at the individual paths, which we just did. You already identified which ones were the non-significant ones. And so we're going to follow that final step of trimming non-significant ones so that we can evaluate overall model fit with the post hoc modifications we made, which included the addition of a couple of lines and now the deletion of a couple of paths.
All right. So we'll run this last model, but before we do, I'm going to run back and just look back at our path diagrams for the previous. We went from, oh, we didn't do one on the first one, that's right. So we went from that to that. And now we are running our model D, which is already entered in for you. Same thing, fit that. So we specify the model as a character string, fit the model with the SEM function, and then assess our model with our model summary. So starting from the top, you see now that we eliminated those two paths, we have gained back 2 degrees of freedom here. In fact, I'm going to go ahead. I'm going to run this thing as we talk about it. No, God damn it. So this is what our diagram looks like now. All we did is we removed this GPA to job score 3 and SRA to job score 3 lines, which is where we got those 2 degrees of freedom back. And when we look at our chi-square and chi-square ratio now, what does that tell us about our fit?
we have a non-significant chi-square, and that's good because our question here is, do the data fit significantly different, or are the data significantly different from the specified model? But of course, we post hoc messed with this model, so it's not a surprise that it doesn't, that it comports with the data. So, but yes, non-significant chi-square is really good. You have to hand calculate your chi-square to degrees of freedom ratio. So you would be dividing 0.628 by 2, which is really under 2 or 3. I know Casey, you said it's close to 2 or 3, but it's actually close to 0.3, not to 3. So it's fits well from that ratio perspective.
And then for our CFI and NFI, as a reminder, the NFI isn't print in the summary there, but you can get it in fit measures with our CFI and NFI here. And what do we want those values to be? Yeah, exactly. Over 0.5, 1 is good. For our RMSEA, we already looked at, remember when we ran that last one, when it's a perfect fit, this zeroes out. But now we have a non-significant p-value on that RMSEA. RMSEA value is, well, it says 0, but that's likely not actually 0, but some incredibly small decimal close to 0. But that upper 90% confidence interval limit is 0.029.
And
Iterate.
what do we want those values to be? Josh, I would just say 0.00. Yeah, Noah's right. We want those values to be under 0.08.
Our iterations prints up here at the top. So this converged in 70 iterations. And again, like as far as Lavon goes, 70 iterations is basically nothing. The default is 500 iterations. So it's not uncommon for these to have to run for a pretty good while, especially as things get, or a pretty good number of iterations, especially as things get more complex. But in this case, 70 iterations, that's a pretty good, stable solution. So what does this tell us about the fit of the model overall? Yeah, overall we have a good fit in our data here. Where do we find these R-square values for our endogenous variables?
Sorry, real quick. Jake was asking about whether the fit indices are always going to look good in the context where you have a non-significant chi-square. And the answer to that is basically yes, because the fit indices are usually a function of chi-square or a function of chi-square difference from the baseline model in some way. They might account for different things like parsimony and degrees of freedom and things like that. But it's rare that you would have a non-significant chi-square but fit indices. It can happen under unusual circumstances. We haven't talked about all the ways models can go wrong. There's lots of troubleshooting that can happen. But typically, if you have a pretty well-specified model with pretty trustworthy paths that converges quickly, then if the chi-square is not significant, your fit indices are going to look good. The reason we have fit indices is because many times chi-square is significant, especially as model complexity grows. And so if we were just sticking with chi-square, almost everything that we ever ran, we would not be able to say fits the data well, or we would have to say there are significant deviations in the data from what the specified model is. So the fit indices were designed to be a more liberal perspective about what model fit looks like by taking chi-square and then doing different things to it, adjusting it for different things. So just so you know, the most likely scenarios, if chi-square is not significant, your fit indices are going to look great. The most common scenario for publication is chi-square is significant, but your fit indices are great. And you have real problems if your chi-square is not significant and your fit indices are good, because that indicate, I'm sorry, your fit indices are not good, because that probably indicates some real specification problems in your model. It is a good idea, Josh, to have declared, just like you would with your nominal alpha, to have declared what constitutes good model fit on the front end in your analytic approach. So that way you don't go back and fiddle and say, well, it's like a marginally significant finding. Like if you're going to say alpha is 0.05, be 0.05. If you're going to say RMSEA will be evaluated at 0.08 or lower and CFI at 0.95 or 0.90 or higher, whatever, say that on the front end. Be explicit about what your stated criteria are for determining good model fit. If you don't see that in the paper, you do have to wonder about whether they're doing that whole like, well, you know, we're kind of making it a abstract art and we see in it what we want to see.
Yeah, so R square, as a couple of you mentioned, is down here and at the very last bit of the output. So GPA 2, about 27% variance explained, education 3, about 34, and job score, about 16%. So where do we look to see which variables were the best predictors of each of these other three? Casey says the standardized all, and more specifically, and z-score, as Jake said, those will line up the same. So when we look at these over here in our regressions tables, so what is the best predictor of GPA 2? SMA. And for education 3, GPA. And for job score, and education 3, exactly. And so what do these micro results tell you about the model?
Every model that we've been working with under every type of analysis for multivariate has included a macro fit and then micro assessment. And the macro is kind of these global fits like an overall MANOVA lambda, or a overall chi-square for your logistic regression, or in this case, an overall chi-square or a fit index. So now what we're doing is we're looking at more specifically at the individual paths within our model, or the individual variable to variable relations. That's what we mean by micro results. Yep. R squared actually is part of the micro results in path analysis because we have multiple variables that are endogenous, and each of them has its own R squared. And so we typically do consider R squared as kind of part of the micro.
Anna, correct me if I'm wrong here, but one way to kind of word the micro versus macro thing is looking with that the macro being, you know, overall how well does the model, does the analysis fit, and then the micro being, all right, what is the answer to the research question that we're putting forward. So one is more about analytically, how does this approach fit? How does it work? And the other is, okay, now what's the answer to the question that we're trying to analyze?
Also, we're not really looking for a very specific question. Like, it's fine to just say that the micro results, like after we trimmed the model, of course, suggest that a large portion of our original theoretically specified model was right, that you know, the proximal predictors of GPA were reading and math achievement, that education, ultimate educational attainment in adulthood was well predicted by those middle school variables and high school GPA, and that finally that job score, or was it job score, was predicted by the high school variables, but also by achievement. So it's fine for you just to kind of just describe that all these paths were significant after trimming, and which ones were the best predictors, and then how much variance we explained in the endogenous variables.
One thing I want to point out to all of you, as far as the final lab, here we'll have a couple days of lecture for CFA that we'll be going through, and then we have one more lab. But the final lab is certainly our shortest one, and it's all of this same stuff that we've been doing here. There are no new functions. It is only difference is, instead of using sim, we'll be using the CFA function to fit our model. But we'll specify a model as a CFA. We'll fit it with the CFA function, and then we'll interpret our summary. But we're still looking at these same types of things, the chi-squares and all that. So just previewing that when we get to the next lab, it will seem like we're not really even doing much different, because from the R side of things, we're not. It's going to be incredibly similar to what we're working on, and what we've been working on for these last couple weeks. Does anyone have any questions? No, the script's not up for the next lab yet. I'll get it posted once we get through the lectures.
Also, the CFA homework assignment Word document that we have up on Blackboard is going to be shortened, so there'll be a slightly updated version. I don't know how many of you download everything when class begins, but I've been providing some updated things as we've made some adjustments. So we did cut the CFA lab relative to what it was in the past, not by much. You'll be able to see what the old CFA homework looks like, and as soon as we post the new one, you'll see that too. How are you guys feeling about path analysis? Yep, the write-up is in the book. Yes, the path analysis one we've been working on is the correct one. Oh, I'm glad you guys are generally finding it to be good. At least the experimental folks who've responded are saying they like it or feel okay about it. It's pretty straightforward. Good. Excellent. So a quick R question about how to make the nodes larger. I'm so
Brad?
glad you guys are feeling good about this.
Yeah, Josh, you are able to manually specify the size of those nodes, the size of the labels that are in it. So instead of being E3 period, you could make it say, EDU3 or things like that. And the SimPaths link that I put up at the top of the script shows all the different arguments that you can put in, and feel free to get in there and play around with some stuff and see how you can present these differently and prettify these real basic sim paths that we put in here today. And then there's also, if you want to look up, there's a library called Diagram R, with a capital R at the end, and that's the one that I would probably use if I was trying to make one for a publication, where it wouldn't automatically happen, but as far as being able to specify positions and locations and all that sort of stuff, it's a little more complicated to use, but it can make prettier plots. So if I was going to have one of these path diagrams in a publication, I'm probably going with Diagram R as what I'm using to make the diagram itself.
Yeah, so the default pictures in Levon are really somewhat challenging in terms of it automatically positions things in certain ways, and they may not be the ways that you would want to present it, or they may not follow convention like this last one we did, where it's going from GPA 2 at the bottom right, up to Education 3 in the middle right, all the way up to Job Score 3 in the top right. And that doesn't follow conventions. We don't typically go bottom up. We either go, well, from my perspective, left to right, or from top to bottom in terms of temporal ordering. But if you can mess around with it a little bit. To be fair, there's a ton of great things that can happen in R. We just don't think it's a good use of our time at this very introductory level to walk through all the ways to make a picture pretty. And so we decided to keep it simpler, just go with the default pictures, just so that you understand conceptually. And then again, in an SEM class or in your own time, if you're interested, or one-on-one, both Austin and I are happy to meet with you to talk about how to make pretty diagrams and paths, both inside and outside of R. What I really wanted to get to know was that you guys were feeling good about the just general tilting on its head of the whole family of SEM procedures compared to all the other statistical procedures we've used so far. It's really not different from the perspective of just regression, right? Just another linear model. Yeah, what's different is the whole macro fit. You're looking for non-significance, and then you're looking at these fit indices, and then only then do you go and start to look at your more micro fit, your regressions and your paths and R-squareds and so forth. So if we feel like this is comfortable, then we can move into CFA. With path analysis and CFA, you have the building blocks for basically all types of structural models. They are the most basic building blocks. So right now I've forced you to build everything with a square, and we're going to add circles to basically our building blocks. And with squares and circles, you can now make everything.